Okay.
You want to dance tonight? At home?
At home. At home. Okay. Bye.
Oh,
Bye. Why don't I see this? Okay, can you hear me? So I lost power and I lost internet, and apparently there was some major outage in Rio Piedras. I heard ambulances too. It's very loud. I'm actually in in a torre, but the generators are going right now. So the fact is that most of the notes are in video form, pre-recorded videos on Moodle. So all I'm going to do is teach a few things and then send you there, and you'll have to work there on your own, all right? That way I'll avoid being cut off again. And wow, and Humacao. Yeah, I don't know all the details. I haven't had a chance to look. I've been trying to reset everything at home. But yeah, my husband said there was some major outage. He said explosion, but I don't want to be hyperbolic. So let's just have an hour together, and then I'm going to refer you to the videos online, okay? Because you do have everything, almost everything in Moodle. So I'll wait for the others to join. If I lose you again, I'm going to have to start another stream, because I lose the chat, and it makes things a little more confusing to watch. I also risk losing the captions. So let's see if I tried to email you with my phone, and that was not very successful. Maybe we'll start a chat for emergencies like this. If somebody, how can we do this? If you guys have a chat, invite me. Do you guys have a chat in the class? If you have a chat, invite me to the chat so that if things like this happen, I can be part of it. Otherwise, delete me from the chat if you guys want to talk privately. I'm not sure how it goes. But we should have a chat between us. It's easier to communicate. I don't have to go on the internet to write an email. Okay, so then I'll just start see if I can start a chat. I'll email you guys and ask for your phone numbers and start a chat in Signal. Do you have Signal? I use Signal. So we'll do that, if that's okay, as opposed to email. I tried to communicate with you. I guess I could do it through Moodle too, but then I have to log into Moodle, and that's slow, and right. Okay, so text me your phone numbers and start a Signal account, and I'll communicate with you there. My WhatsApp is over full, and I need to clean all that up. It doesn't work properly. All right, so let's do this for about an hour, and then I'll refer you to the Moodle page for videos, which I guess you have to watch on your cell if you don't have power. I don't know how much data you guys have, but that's the best I can do right now. We'll see how things are tomorrow. We'll see the situation tomorrow. Okay, so let's see. Let's regroup here. I'll tell you my... Text me at that number. All right, so what we want to do, now that we've learned about gathering data and properly gathering data, either in experiments or from surveys, what we want to do now is analyze the data. So what do we want to see? What do we want to look for? We begin with displaying the distribution of the data. What is a distribution? A distribution of a variable tells us what values it takes and how often it takes those values. So the way that we begin is a graphical representation of the numbers. And I'll show you a few ways to visualize data, but it's the same principle as, this is my goal. I want to be able to see what values the distribution takes and then how often it takes those values. So I want to display the numbers in order, and somehow I want to look at frequency, how often certain values are realized. And I group together similar numbers so that there's not too much detail. I need just the right amount of detail in my graph to see patterns. Not too much detail, then it'll take away from seeing a pattern. So I want to group things together in a certain way. So I'll provide instructions on how to do that most of the time. Or just give you graphs and you have to analyze the graphs. Okay, I'm getting your phone numbers, that's good. So I'll make a chat if we lose contact again. And just start a Signal account. So we begin with a graphical representation, and then depending on the graph, we calculate certain summary statistics, okay? The summary statistics depend on the 5 features of the graphical representation. So depending on those 5 features, a different set of summary statistics should be reported. For categorical variables, I mentioned before, use frequency distributions like tables, or frequency distribution tables and graphs such as bar charts, pie charts, and Pareto diagrams. So you have an idea about what these things are. You can see, you can look at Pareto diagrams to see some examples. This is something you might have seen or come across in reports. We're going to focus on continuous data, and well, not just continuous, but quantitative data, either continuous or discrete. And these use stem and leaf displays, histograms, ogives, which I won't talk about, and box plots. So you can just look that up to see some graphs, what that looks like. In addition, when looking at 2 variables at a time, not just one, you can represent cross tables of data, time series plots, or scatter plots to visualize your data. So we're going to begin with the stem and leaf plot. I'm going to show you how to do this. Is just an outline of what we have to do, but I'm going to take this as an example. This data is presented as the second data set in the sample problems data set. So here is the data and the question. So the data is the spending of 50 consecutive shoppers in a grocery store. And the questions are, how much do shoppers spend in the store? And how can the data help improve the store's marketing strategy? I've begun by putting the data in order. So I put it in order, and it's in dollars and cents. And then I group together groups of numbers, intervals common intervals, I've called them classes. I mean, common numbers have been grouped into classes. And the first class of data are the values between 0, 0, and 0, 4. I'm using 2 digits because the last value is 69. It has 2 digits. But what about the decimals? What have I done with the decimals here? The first value is 232. The second value is 661. So what I've done here is for all values between 0 and $4, I put the first digit here, which is 0, and the second digit here, which is 2, and I have rounded the decimal places. Okay, so I mentioned earlier that you don't want excessive detail. You just want to be able to see a pattern. And I'll describe what exactly you want to see in the pattern in regards to the 5 features of the distribution. But I'll tell you right now, the 32 cents is not important, but we should incorporate it properly. We'll round up if there's more than 50 cents spending. So this one gets rounded to become just $2. This one gets rounded to be 7. This one 7. This one 8, this one 9, this one 10, this one 11, this one 12. Okay? So here you see the 2, you see the 0, 7, you see that the first one is, the first one here is 10, and this one you see 11, you see 12. Okay, so if you've never seen this before, it's a little bit strange, so I'll spend a little bit of time explaining this graph. So I don't want any of the classes to overlap. So this one goes from 0 to 0, 0 to 4, and then the next one starts 05 to 09, the next one 10 to 14, and then 15 to 19, and 20 to 24, 25 to 29, 30 to 34, 30, you get the hang of it, to 39, 40 to 44, 45 to 49, etc. So there are 50 observations, and I rounded up the numbers, but because the last one has 2 digits, 69, all of them have to have 2 digits all the way through. Okay, so what's going on here is they share the same first digit, but then the second digit is different. So this is the 6. Why did I put 6? That's a 7. I said 7, I think, and I wrote 6. That's a 7. And then 8. So this goes 7, 7, 8, 9. 7, 7, 8, 9. And the next one is 10, 11, 12, 13, 13. 10, 11, 12, and then this rounds up to 13 and 13. Okay, so you round up to the next whole number. So by doing this, now we see a pattern. We see a pattern. And what I can do is I can smooth out that pattern. I could think, well, when I smooth out, I'm saying that I believe even if there's more data, even if I had all the population of data, the pattern would still be about like that. That's what I'm saying by smoothing. Now, usually we see this on a horizontal, right? It's usually written or drawn like this. Let me move this over. So it's usually seen like this, where the number line here goes from small to large numbers. And we could debate about whether if there were more data, these gaps would fill in, and you would just get something like that instead. Let me make it more. Okay? Which would imply that there's no distinct characteristic happening here that's making these group together. That it's just a smooth curve saying if I had more data, if I had more information, if I had information on all shoppers over the whole entire year, then this would be the pattern that just a few people spend a lot of money and most of them spend a modest amount. Okay, so we could debate which one it is. Now, you have to have a story to back up which one you would pick. And you'll see in my notes that I stick with the yellow curve. So this is called a density curve. I call it idealized distribution of the data because I have the entire population of data to speak of. So when I smooth, I'm saying that I presume it'll be like this if I had all of the data. I'm going to put the word smooth over here. So any questions about drawing this? If you were to draw this, you have to keep these columns steady, aligned. So it shows you in this way how many observations fall into each class. So which is the most frequent class? This one here, between $15 and $19. How can I say this? The most frequent class, the modal class, is between $15 spending and $19 spending. So what we want to do with this is summarize what we have. It's only one variable. And when we have one variable, we report on the 5 features. The first one is the shape. In this case, this has what's known as a left skewed shape. Why did I say that? Not left. Now I'm going to confuse you. My mind is wandering. It's right skewed shape because there's a tail on the right. A tail implying a few people relative to the rest. A few people spend a lot of money. There's 4 people here who spend over $60. That's 3 times the group over here that we identified as the most frequent class spenders. So this is right skewed. It's not symmetric, or it's asymmetric. Now, because of the shape will determine the other, a few of the other statistics that I'm going to compute, or a few of the other features that I'm going to comment on. So the second feature is known as the center. It's the expected value of the distribution. Remember, we discussed how statistics helps alleviate uncertainty. It also can help you make predictions then. I mean, that's the flip side of that. You can make predictions, and you could even have fun with it. You could say, hey, I'm going to try and predict how much the next customer spends in the store. Looking at the distribution, showing the values that the variable takes and how often it takes it, which class would you bet on for the next shopper? Or which value, which amount of spending would you bet on? I'm asking you. Would you bet that the next person spends more than $60? Probably not, right? Because that is rather rare. Most of them are around here. Okay, so Nivette threw out a number, 21. She would bet on 21. So she would bet around here. Okay? That's good. So she didn't go for this one, because here, this is what we call the modal class. That's the most frequent class. Mode is the most frequent observation, but obviously there's no single observation that's more frequent. It's the class that we really look at when we group data like this. So we would compare the modal class. That's one notion of expected value, but it turns out that when data are skewed like this, you wouldn't pick the mode as the place mark where people would, where you'd expect the next observation. Another measure of center that is common is the mean. The mean, or the average, would be where we would have to add up all these values and divide by how many there are, right, to average them. When you do that, I'll just give you the value so that we don't have to calculate it right away. I'm having trouble opening files. Hold on. I'm not sure why. I think my computer's freezing. Please don't freeze. Okay, it opened. Okay, I found it. 25.86. So the average turns out to be $25.86. So the average would be in which class? It would be, you have to round to 26. It would be here. Okay. Now Yvette mentioned 21, which would be just between the two of them. And in fact, the modal class is not the best guess when you have skewed data, and the mean is also not the best guess when you have skewed data. It's somewhere in between. The measure of the median will probably fall in here, and that's a better estimate of the expected value. What is the median? So mean is the average. The average is to adding all the numbers and dividing by the total. So it uses all these numbers in the calculation. So that means that the mean is going to be affected by these very high, rare numbers. So the number will be more like these high numbers over here. And that's why it's over here, away from the mode, and away from where the median will fall. Median is the middle value. It doesn't use all of the values like the actual number in its calculation. It's just the position of the middle value of 50 observations. So the way that I've laid out the data here, you see I've divided it in two. The median is found in the middle, the average of the 25th and the 26th observation. So the median is actually, so when data are skewed, we use the median. And the median is equal to the n plus 1 over 2 observation. N is the small n, the sample size is 50, so that would be 51 divided by 2, or 25.5, which means that you compute the average of the 25th and 26th observation. It doesn't involve any of the other numbers, just the middle two numbers. Okay? So in that sense, it's not affected by the skew, it's much more stable, and it tells you where, well, not stable, but more representative of the middle of the distribution. We say the mean is sensitive to the outliers. Okay? It's drawn away from the natural center. So that is going to be the 25th and the 26th is exactly like Nivette said. So even though my drawing was with the rounded values, when I make calculations of statistics, I go back to the original values, all right? I don't just use the rounded values. So it was 2074. She was very right. I guess you hear that big noise outside. It's the generators. Okay, so the median is 20.74. So about $21, like she was right. And it's going to fall in here. So I explained the reason why this is the case. The mean is actually it's also called the expected value, but it's not a good measure of the center when the distribution is skewed, because it's the center of gravity. And if I try to take a distribution and balance it at the center of gravity, it would have to be somewhere not too close to the majority of the data, because it has to balance off this long tail. So it can't be like that, too close, like it's here is at the mode. But it can't be too far away, because then this will topple over. It has to be slightly away from the mound of data, pulled towards the tail to balance the distribution. So that's why we instead use a measure that is not affected by all the values in its calculation. This one just used the two middle values to calculate it. All right, so that's for the center. Now for the spread. There's lots of activity outside here. The next feature is known as the spread. Sure, we have the expected value, but one number doesn't do justice to all the variability of this distribution. We have to know about how certain or predictable that expected value is. So you gave a median of 21, but what else could it be? You know, how variable could it be? How different could it be from $21 or $20.74? So we want a measure of spread. When the data are skewed, the measure of spread the measure of spread should not be affected or sensitive to those outlier or extreme values. All right. So instead we use something similar to the median. First, we could say something about the range of values. We could compute the range as the maximum value minus the minimum value. And that gives you an idea of how spread out the values are. Now again, using the original data, 6949 is the max, and the min is 232. So it's spread out by $67.17. And then you want to mention what's called the 5-number summary. The 5-number summary is made up of the minimum value, the first quarter, the second quarter, the third quarter, and the maximum value. What am I talking about quarters? I'm talking about its position in the rank order of the data. So this actually has the name of percentile. This is the 25th percentile. This is the 75th percentile. And it also has the name of first quartile is the 25th percentile. Third quartile is the 75th percentile. And in between, in the middle, you have the 50th percentile, or the second quarter, or the second quartile, or we call this the median. So this is just the median in the middle. And like the median is the middle observation of all of the data, once the median splits the data into two, the 25th percentile is the middle of the first half of the data, and the Q3 is the middle value of the second half of the data. So we're going to use that approach to calculating the 5-number summary. So this way of summarizing the data, it does show us how spread out things are, and I'm going to demonstrate, and I do that in the videos too, how we will examine like how the quartiles, what the quartiles tell us. If we were just given the quartiles, what does it tell us about the distribution without seeing the data? I see the data here, so it seems redundant, but I want to show you how useful the 5-number summary is. Okay, so what we're gonna do is we have the median. Now the median was between these two observations. It's actually not a value, but the median is not included in the analysis of the other quartiles. It's used to split the data in half. So here we have the first half and the second half of the data. So now what I want to find is the middle observation of the first half, and then it'll be easy to get the middle observation of the second half. So how do we do that? Well, just the same way as we got the median. I can visualize it here, but you can imagine if you have lots of values, you need a tool to find the median easily. So let's use that tool. One moment, I have something in my eye. Goodness. Oh, gosh. One moment. Okay. So we're going to use the first half of the data. The first half has 25 observations. So I'm going to clean this up a bit. Do I need to make it bigger, or can you see that? Let's make it bigger. We're going to use the rule n plus 1 over 2 is the location of the median of the first half. And I'm going to use the n of 25. So that's 13 and a half. No, sorry, 13. So this is actually the first quartile. And then directly over here would be the second quartile. It'll be the 13th observation. 1, 2, 3, right? All the way down, but I've lined them up so that you can visualize it here. That this is also the 13th observation of the second half of data. So that's Q3. So we're really done. We have the minimum, first quartile, second quartile is the median, and the max. So let's put them all together in the 5-number summary. And we use the original values, remember. $232, $1435. Then the median was found to be $20.74, and the max was $69.49. That's the 5-number summary. Any questions? So what do I do with this? I do explain this in the notes and in the videos as well. What I would do is I put these on a number line without all the details of the stem and leaf plot and create what's known as a box plot. What I'm going to do is do that in the space that I provide. It's on a different page, but I'll put it there just because I've measured it out neatly. I want to use that page. I have a graph somewhere. Okay. Okay, on page 16, I have a nice laid out number line. And I described this in the video, so you'll get to go through this again. So I've spread out, actually, you know what I'll do? I'll take it away from here. I'll take it with me. So what I'm going to do so I've spaced this out so this works. This is $2. This is the min. This is the max. This is Q1, Q2, and Q3. This is $2.32. This is $14.35. This is $20.74 and $69.49. Oh, what did I do? I missed one. Oh, I missed a number? Oh, I missed putting the Q3. You guys, did you tell me? Yeah, I just noticed. Okay, let's put one more. I'm gonna move it over. Sorry, it's very loud here. $20.74, 33.80, and 67.17. There. That's my 5-number summary. Sorry. And then 33.80, 67.17 maximum. So now I can make the box. So this is a box plot. And what do I do with this box plot? Well, it shows me the spread of the data without giving me all of the numbers. Okay, so it's a very simplifying way to look at the data. Now, if you just got a box plot and you didn't get all of the details, what would you know? Well, you can actually see the skewness. The way that you look at skewness, and I have a video explaining all this, is you start inside the box. So this is the middle 50% of the data, right? I've divided the data into groups of 25% of the data. So these ones are, this is 25% of the data, this is 25%, this is 25%, and that is 25%. So if there's 100 observations, there would be 25 in there, in that range. There'd be 25 in there, 25 and 25. In our case, it's half of that because there's 50 observations. So we begin in the middle 50%, and this tells us about the regularity of the distribution. And what you see in the middle is that the second half of the middle is more spread out than the first half. So this shows that there's slight right skewness. Then when you go outside of the box and you look at the other, other data away from the regular center expected value, right? Because Q2 is the expected value. Away from the expected value, what do you see? You see much more skewness on the right side. So you see that inside is telling you that it's right skewed. And then outside, it's also telling you that it's right skewed because I'm comparing this to this, and this is longer. Now, you'll see in the notes discussion, they talk about this being the whiskers, right? This is like a mustache whiskers of a cat. I mean, I know it's not a mustache on a cat, but anyway, it's the whiskers of a cat. And that's what you can see. So without seeing the data, that's what it tells you. The second thing that a box plot can tell you is whether you have extreme values that we call outliers. Now, people can talk about values being set apart from the rest of the observations and call them, very loosely outliers. But in statistics, we have a very rigorous way of checking if it meets the standard of being an outlier, a statistical outlier. And the standard is to say that data is going to be considered unusual or strange or set apart from the rest of the data when data are skewed like this if this box, sorry, someone's writing me. Yeah, I'm not going to talk too much more because people are having problem with power and it's stressing them out. But I just want to finish this discussion because it's not, well, I guess it is in the notes, but the drawing is not. And I wanted to just finish this one. I also wanted to do the Maris and Ruth one, but I'll leave that to you to review in the notes, and then tomorrow I will talk about it a bit. Oh, what's this number? Sorry, I don't know what's going on. Where did I get that number from? Oh, I was using the range. Sorry. I'm sorry. I'm very distracted right now. It's very loud outside. And yeah, sorry. I'm not even reading the chat. I'm just trying to concentrate, and I'm making too many mistakes. Okay, sorry. So this is just the maximum that I circled already, 69.49, and this is 69.49. All right, so what was I saying? So what we need to do is take this distance, this is okay, I'm going to do that again. That was not a good idea. So this distance here is the range of the middle 50% of data. This is the middle 50% of data here. So what is the range of the middle 50% of data? The middle 50% is called the interquartile range, IQR. And you calculate it as Q3 minus Q1. So that tells you how spread out the middle 50% are. When you calculate that, what do you get? Okay, so the middle 50% is spread out by about $20. So what we're going to use is that as a reference range and say if the data is spread out 1.5 times, or if there are values that are more than 1.5 times this away from the interquartile range, we'll call it strange or an outlier, a statistical outlier. So what we need to do is put ourselves in a position that's 1.5 times I didn't realize I erased so much. I want to put myself so where would this be? Add 1.5 times the range, the interquartile range, and where do you end up? Okay, so I was just saying that this is called the 1.5 times IQR rule, and to find out the limit, the threshold after which there are extreme values considered statistical outliers, it would be beyond 6296. I calculated it by adding on to the interquartile range 1.5 times the IQR. Did I make a mistake? 3380. Oh yeah, I don't know. I did have that number, but I read it, I don't know what I'm doing. Rounded down. So 98. Still doesn't change my answer, but thank you. You guys are awake. All right. So that's the third feature. And this is how we can use box plots for skewed data. So this result is all for skewed data. If the data is not skewed, if it's symmetric, symmetric would be the mirror. Symmetric is that bell shape. This would be symmetric and single peaked. Okay? And in that case, you could also have a very flat, symmetric distribution, and you might want to know if there are extreme values. So if the distribution is symmetric, then the shape would be symmetric, right? The center would be the mean, the average. The spread would be, a measure of spread would be the standard deviation. And I have a video to explain how to calculate the standard deviation. You should be watching that after this class. How to calculate and what it means. And with regards to spread, I won't talk about the fourth. With regards to spread of a symmetric distribution, values outside the interval x bar, because the mean will have the symbol x bar and the standard deviation will have the symbol s, values outside x bar plus or minus 3 standard deviations will be considered statistical outliers. This is all in the notes, but I'm mentioning it now. So you'll get a chance to practice that, okay? So that is the standard for outliers in the case where there's symmetry. So that leaves 2 features. The remaining 2 features are the number 4 is peaks, and number 4 is gaps and outliers, and 5 is peaks. Now we've already done the outliers part, so I'm just going to call this 4. Are there any gaps in the data? Let's look at our, if we look here at our distribution, is there missing data in any of the classes? Yes, there's a gap here. So this is really interesting because the gap, it denotes a break, right? There's a break in the data that sets apart these. Not all of them are statistical outliers, but most of them are. This one is, and this one is. So there is a gap. We would have to mention the gap. 55 to 59 is a gap of data. There's no data there. And you still have to draw it because it shows how the data is spread out. So these are my sketch notes, of course. It's neater in the notes itself. You'll see a neater copy. So gaps, let me write it higher up. So I've already talked about outliers and just mentioned that there's a gap. In 54 to 59. Right, there's no data. And the fifth feature is or are the peaks. Now this is where the storytelling sets in. What I see here, I've told you, I believe that there are, even if I had more data, I believe that it would still stand that there are three groups of shoppers. There are maybe something to be looked into. Maybe these are low-income shoppers, these are middle-income shoppers, and these are high-income shoppers. That could be. So that's something we could investigate. And that would be important because then we can think about on what products to market to the shoppers. Now these four people spend, I think they spend more than the others combined. Because this one, so it's like about 60 times 4, right? 65 times 4. So these four people spend about $260. And, well, a good fraction of what's spent by the others is spent by these people. And if I took the mean, I could figure out quickly. The mean is 2586 times 50. So the total spending of the 50 shoppers could be calculated as the mean of 2586 times 50, right? Everybody's okay with that? And that makes $1,294.50. So these people spend a quarter, well, a fraction of what is totally spent. So maybe it would be interesting, to consider offering more products to these customers, or maybe they're not customers. Maybe there are other businesses that are buying bulk stuff for their business. To either they're a restaurant, maybe they're a restaurant, and they're buying some supplies for their restaurant. So we'd have to find out who these people are, but there's definitely 3 groups that we have to identify. And if we don't know, we could suggest further research into finding out who these customers are. So these guys spend about $260 or about $300. Oh, I used 65 anyway. I won't put it because I didn't add them, I just estimated. Okay, so the peaks are 3. There are 3 of them. One is here at 15 to 19. One is here at 30 to 34. And one is here at 60 to 64. Is that correct? All right. So that is the 5-number summary. I've done it for the spending data, and I've given you insight to how to do that for symmetric data. And it's almost 8 o'clock. Do you have any questions for me? I think somebody wrote about the Saturday exam. The Saturday exam will be everything we do up till tomorrow. So you should spend tonight and part of tomorrow looking at those videos that review the notes. I've done an overview with this exercise, and most of the pages are tackled in the notes. So just make a note of the pages that you don't understand and anything I need to review. I already have an idea of what I need to review and or to discuss if you didn't get through it. So I'll pick up tomorrow's class with those topics. Okay, do you have any questions for me right now? So in the sample problems, you can read a summary of this analysis and then all the other 3 data sets that I introduced. So I'm going to try and do some normal distribution material tomorrow, but if not, we'll just make the test on what we finish tomorrow. So it is an intensive course, so you do need to dedicate substantial time to covering the material. If you have problems accessing Moodle because of power, well, let me know. If you actually have absolutely no power, I don't know how you're going to charge your phone and watch videos. So just let me know what's going on, your situation. Write me a text or an email privately. go to Moodle and see in Unit 2 GDS, there are a ton of videos you can watch. It covers all the notes, all the pages of the notes. Good night, Yvette. Good night, Valeria, Alexandra. And let me know your situation with the power. Yeah, go right to Unit 2 and watch the videos. You'll see I have all the pages discussed. Now, in the videos, I explain how to use a calculator, but not this calculator that I've asked you to buy. So you can work with your calculator to figure it out, but we can talk about that tomorrow. We'll begin with the calculator material, the calculator discussion. But make sure you watch the videos for the standard deviation, okay? I'm just making a note. That's where we're going to start the calculator discussion. Good night.